All it asked us to do in activity 1 was to first graph them and then figure out the coordinates between our pre-image and our image. So, ABCD is the smaller figure. Your image is your larger figure. So that's where your primes are. Now, you also went ahead at the same time after you did the dilation, you also went ahead and did the translation so that it was kind of skewed off of it. All right, because otherwise it would be almost right on top. All right. Now, what did you guys notice? What kind of happened? Specifically when you were dilating. All right. What kind of happened here? Okay, that's fine. Let's keep going to the next one. So, again, between the first and second coordinates, what specifically happened? So if you look from these coordinates to the new coordinates, what happened? They doubled. So in other words, you multiply the x and y by 2. All right. Now, dilation just means that we are multiplying our x and y value by some number, whether that be a whole number or a fraction. All right. In other words, we're making the shape bigger or smaller. So before we even go further, is a dilation a rigid motion? No. It's the only transformation that we learn that's not rigid. This is the only non-rigid motion. Why is it non-rigid and not rigid? William. It changes size. So remember, for it to be rigid, it has to make congruent images. So same size, same shape. Dilations make the same shape, but they're not the same size. All right. Now, that scale factor is what you end up multiplying by. All right. So your scale factor should have been 2. That's what you multiplied by to get from the image to the pre-image. So if it ever says dilate a figure by a scale factor of 2, that means multiply everything by 2. Scale factor is 3, multiply everything by 3. Scale factor of 1/2, multiply everything by 1/2. All right. And again, that's what you kind of should have figured out as the hypothesis. Now, what happened for activity 2, what happened between our pre-image points and our image points? What happened? Say that one more time. It got smaller, but specifically, mathematically, if we go from the pre-image to the image, what do we actually do? We divide it by 3. Now, I want to say that in terms of multiplication. So if we're dividing by 3, that means we're multiplying by 1/3. All right. So our scale factor in this case would have been what? 1/3. All right. So yes, we're still dilating, but our scale factor is by 1/3. So make a note that when you multiply, you write the scale factor in terms of multiplication. So in other words, if you're technically dividing, that means you're multiplying by a fraction. And it's really easy to figure out that fraction. You just flip it. All right. So like if you're dividing by 3, that means you take the reciprocal of 3, 1 over 3. That's what you're multiplying by. Now, this is our rule. So if you start with xy and you're dilating around the origin, which is the only type of dilation that we're dealing with, that means that if our scale factor is r, this would be our new point. So r times x and then r times y. And again, that's with a scale factor of r. Now, activity 3, if you got it, great. This one was more of could you figure it out? But typically in this class, I just expect you to know how to do it around the origin. All right. So I'll still talk about 3. So if you're practicing dilating center around point other than the origin, you already plotted Hij, and you want a scale factor of 2 centered at the point 1, 1. So if it's at the point 1, 1, that's this point right here. So instead of the origin, we're doing it based off of 1, 1. Now, that means that if we multiplied 2 times negative 2, all right, that means we have to do it based off of its translation, okay? So, and by translation, I mean look at how it's translated from 1, 1 to each point. So, for example, with H, it's 1 to the right, 3 down. It's a proportion. So that means we multiply those proportions by 2. So that means our new point, or H prime, has to be 2 to the right and 6 down. All right. Now, any other, like I said, I only expect you to know how to do it around the origin. But this may pop up as, say, a bonus question, where if you have to do it centered at another point. All dilations are proportional. Technically, when we did it up here, if we talk about from the origin, all right, let's say I did from point G and G prime. I would go left 1, 2, 3, 4, 5, 6, and then down 1, 2, 3. Well, we're doing a scale factor of 1/3. So if I divide both of these, that means I should do from the origin to the left 2, 1, 2, and then down 1, which is exactly what I did. So that's another way that you can do dilations. Think about it in terms of a translation. Just think they're translations from center point should be proportional. And again, that just means that you can multiply or divide and get your starting one. And again, I mainly just want you to know centered around the origin, but there may be a bonus question on the test on your way that way with that one. All right. Any questions? All right. So your summarize is what you guys will list out. So list 3 words or phrases that sum up the geometric dilations. Again, it's similar. There's a size change. There's a scale factor. That's just a sample answer. If you can think of more words. So maybe another one. Multiplication. That might be another one. Proportional. All right, those are just some examples of words. Now, it does say that based off of them, they are similar. What's the difference between similar and congruent? Does anyone remember what the difference is?
Congruent means that they're like equal, or similar just means like it can be the same shape but bigger, like it's dilated or smaller.
Right. So essentially, congruency means same size, same shape. Similarity means it's really just the same shape, but they can be different sizes. In other words, congruent equal, similarity proportional. All right. Those are kind of the two words that coincide. So congruence, the word that coincides with it is equality, equal, whereas similarity, the word that coincides with it is proportional. Meaning both of them will contain the same shape, but only congruencies will have the same size of everything. Similarity, it just means that the size may be bigger or smaller, but they're still proportional to the original. Meaning we can multiply the same number to all of the sides lengths and get our new image. All right. And then when we talk about dilations, it's really all about size and location. All right. Now that extension part, that's kind of like your check understanding. That's for you guys to do on your own. Any questions on the discovery part of the dilations? All right. So now let's go ahead and take the formal notes. So go ahead and take out your packet and turn to page 21. All right. Yes, sir. Just create a figure with 6 coordinates. All right. So, talking about the formal notes for dilation. So, with the dilation, again, it's a transformation that moves each point on the original figure along a straight line drawn from a fixed point called the center of the dilation. Now, it must include that scale factor, which again, that's another name for the ratio, and the center of dilation. And again, for this class, your center of dilation will more often than not be the origin. All right. Now, dilations produce figures that are the same shape as the original, but not the same size. So we already talked about this, but what category of transformation does dilation violate? It's not what? Well, it's not congruent, but I'm thinking it's not rigid. Good. So technically, that you were correct as well. It is not congruent, but technically, it's not rigid motion. So it violates rigid motion. So this is our first type of non-rigid motion transformation. It's also the only type that you will learn in this class. So if I ever ask you on the test, what is the only non-rigid motion transformation? Dilation. All right. Now, If we're talking about a scale factor greater than 1, meaning we're multiplying by a whole number or even a fraction greater than 1, so like 3/2, for example, we call that either an expansion or a stretch because we're stretching it out. Now, if it's a scale factor less than 1, we call it a reduction or compression. So these two words specifically, take note of them because you will hear them again when we talk about function transformations. All right. It's also a big Math 3 topic. For example, last Friday I taught my Math 3s about function transformations. One thing they had to talk about was the dilations of functions. So vertical stretches, vertical compressions, and it means exactly what you think it means. All right. Now, these are just some properties of dilations. So again, between the image and the pre-image, it's the same shape, not the same size. Even though the angles are moved, the angles are the same measure. The ratios corresponding to the line segments are given from the scale factor. So in other words, if I said that line BC on this figure right here was a length of 2, and from the image to the pre-image, sorry, I said that backwards, from the pre-image to the image, we multiply by a scale factor of 2, that means that BC would be a length of 4. All right. The area increases by the scale factor squared. Why would it be the scale factor squared and not the scale factor? What specifically about area makes it squared? It's two-dimensional, right? So that's what we're talking about with area. So if we look at the lines are one-dimensional. So that's why when we multiply by a scale factor of 2, we don't have to square it because it's one-dimensional. Area is two-dimensional, meaning it's the space within a 2D figure. So you have to square it because you're accounting for the fact that it's 2D. That's why when we deal with 3D figures and you're finding the volume, you cube it. All right, that's why it says, like, when you look at the units, it's like centimeters squared, meters cubed, or just meters, depending on what you're finding. All right. Now, also, the dilation does not pass through the center of the dilation. It travels parallel to the original image. So in other words, unless you have a point that's on your center of dilation, it is not going to actually go through your dilation. So in other words, for example, with the first image on the left, if it has, let's say you were centered around the origin, notice how the center point is here and none of the new points of the red figure go through that point. All right, if it does, you probably did something wrong. Now, dilation which passes through the center of dilation, meaning your original image started there, it travels on the same line. So, like, for example, over here, our center of dilation, probably the origin, but point A was on there. So if we look, our dilation is still within that x-axis. Now, when we're talking about the center of dilation of the origin, the center of dilation, again, we're mainly dealing when it's at the origin, meaning we can just multiply the coordinates of the vertices of the original figure by the scale factor to find the coordinates of the vertices of the dilated figure. So in other words, this is our rule. If we start at point xy, it'll be mapped onto the point kx, ky, where k is the scale factor. Now, another way to write a rule for dilation, you would see it as a big D with a little number in the corner. That's your scale factor. So in other words, if I gave you that, that means you're multiplying by a scale factor of 2. Any questions so far? All right. So let's do an exercise together. So, giving the following transformation rules, they already plotted ABC for us, and they gave us this rule. So, first off, given our rule, what's our scale factor for our dilation? 2. So our scale factor is 2. Now, we're going to map the points, meaning we're going to figure out what the new points will be before we even graph them. All right. So A prime, how would I find A prime? What do I need to do? Multiply both of the points by 2. So I'm going to do 3 times 2, 4 times 2, which means A prime is now what? 6, 8. All right, B prime, we would do the same process, multiply it by 2. So that means my new B prime is what? 8, negative 4. And then we do the same thing for C prime. So guys, on your quiz, this is where some of you guys lost points. If I ask you to map the points below, it means I need to actually have you write out the points. All right. So from A to A prime, what's a new point? All right. So if you lost points on those, you may have the correct points on your graph, but you didn't actually tell me what the points were. So I gave you some credit, but it was only partial. All right. So C prime in this case would be negative 4, negative 2. So if we take a minute to map it out, I would have at 6, 8. That's my new A prime. 8, negative 4. That's B prime. And then negative 4, negative 2 is C prime. So this would be my new figure. All right, any questions on exercise 1? All right, example 2. We're dilating this parallelogram using the origin as the center by a scale factor of 1/2. So it means we're multiplying by 1/2. So what essentially are we doing? We're dividing by 2. All right. So we're just going to go through the points together. If you want to graph it on your own later, that's okay. But just for time's sake, I'm not going to graph them. Because I trust you guys. You guys are pretty good at graphing. Okay. So S, if we multiply by 1/2, what's my new point? For what? For 5. All you got to do is divide by 2. That would be S prime. What would T prime be? 3, 3. Just divide 6 by 2. U prime would now be what? 6, 3. V prime would now be what? 7, 5. All we had to do for all of these was just divide x and y by 2, or multiply by 1/2, however you want to state it. All right. Take a minute, try that last example on your own. So do the you try. And again, you don't have to graph it right now, just map out the new point. All right, thumbs up if you're ready. All right. So remember, scale factor of 2, that means you're multiplying x and y by what? 2. So if you multiplied x and y by 2, those should be the points that you got. All right, last little bit. So this is just a theorem that comes with dilations. So if line segment AB is dilated using the center point C, not on segment AB, with a scale factor of K, then that means the length of A prime, B prime is just K times AB. I already kind of mentioned this already. Also, that the segment A prime, B prime is parallel to AB. So that little like double line thing, that just means parallel. That's the shorthand for writing out parallel. All right. So in other words, let's say that it was a scale factor of 3. Let's say A was 2, or segment AB was a length of 2. That means that the length of A prime B prime would just be 2 times 3, or 6. All right. Now, in the image below, MN is the image of KL after a dilation centered at point C. So, we're going to locate and label point C. All right, so where do you think point C would be on this? It may not actually already be drawn on it. So remember, if they're parallel to each other, that means that, let's say that it was right here. All right. If I just drew the line, oh no, that's wrong. Let's say that I did like this. So I connected the two lines that are not parallel to each other. This would be about where point C would be. All right. Essentially, if you connect the two lines that are not parallel to each other, because we know that MN has to be parallel to KL, then we're good. Now, how do you think I would find the scale factor? Because obviously there's not something nice that we can multiply to get from 12 to 16. But how do you think I would find it? Say one more time. Not quite. Right. You can just write as a fraction. So we go from image to pre-image to find that scale factor. So in other words, if you do 16 over 12, well, what's that fraction simplify down to? 8 over 6, which simplifies down to 4 over 3. And then we can check ourselves. So if we multiply 12 times 4 over 3, all right, that'll be 48 over 3, which is 16. All right. So that means K is equal to 4/3. Now, if we explain why M and LK must be a trapezoid, all that defines a trapezoid is it has one set of parallel lines, and we know MN is parallel to KL. So you'll learn more about the properties of quadrilaterals when you get to Math 3, but typically what defines a trapezoid is just one set of parallel lines. So, and we can already assume, based off of our theorem from above, since we dilated, that MN is parallel to KL. So again, if it ever asks you to find the scale factor, just do whatever the image is divided by the pre-image, and that will give you your scale factor. All right, any questions on any of this?
Why did you multiply the 12 over 1 and the 4 over 3?
Just to check that I had the correct scale factor. So basically, this is just a check to make sure that if I went from 12 and I multiplied by 4/3, I would get 16. All right. Because sometimes with fractions, I sometimes get confused which one I divide by. So that's kind of like my check. All right. So your homework for tonight is pages 23, 24. Is that correct? Yeah. 23, 24. So in other words, you're finishing up that packet. Now, one other thing. So this is not due until Friday by midnight, but there is a Delta Math for you guys. That's not your Delta Math. That should already be assigned to you. So you guys should already be in Delta Math, but angle triangle review, this Delta Math will be due Friday by midnight. It's pretty short. It shouldn't take you only 30 minutes, but basically all it's doing is it's reviewing basic properties of angles and triangles. Now, doesn't really go along with this unit, but it's necessary that you know this for our next unit, which is all about congruent triangles and their properties. All right. So you need to have that Delta Math done Friday by midnight. Yes, sir. Oh, those are Math 3. You guys don't want to do those. These three, this is just my list. So if I just say, okay, this is for your class, that's all you guys got. So yeah, my list has all my classes in it. That's Math 3 stuff. You don't want to do that. All right. Yet. All right. So you guys got about 5 minutes left of class. No, we don't. We have 20 minutes left till class ends. So you can use that time to work on your homework. If you finish that, you can work on that Delta Math. Yes, ma'am. Okay, that's weird. Yes, yes. Yeah. Sign out, take the pass. Uh, give me 1 second, Ashley.